Welcome back to my channel. In this video, I'll be discussing some techniques in factoring polynomials. Being able to factor polynomials is an important skill in mathematical Olympiads because some of the questions presented in this kind of event is solving systems of equations which most of the time require factoring. It is also helpful to remember some important algebraic identities. For example, the difference of squares, the perfect square trinomial formula, the sum of cubes formula, the difference of cubes formula, and so on. Now, why is this helpful? Because most of the time, factoring requires recognizing a certain pattern that fits in each of these algebraic identities. Alright, let us now have our examples. Example number 1. Factorize x cubed minus 3x squared plus quantity a plus 2x minus 2a. Notice that the first two terms have a common factor of x squared. However, we cannot find a common factor of x squared also in the last two terms. So, what do we do now? What if we expand a plus 2 times x? What happens? So, if we do that, we will have x cubed minus 3x squared plus ax plus 2x minus 2a. Now notice that if we group the first two terms and the fourth term, what I mean is that if we have x cubed minus 3x squared plus 2x plus ax minus 2a, and then factor out x in the first three terms, we have x times x squared minus 3x plus 2, and then also factor out a in the last two terms, we have a times x minus 2. This is actually a good thing because x squared minus 3x plus 2 is factorable into x minus 2 times x minus 1. So now we have a common factor of x minus 2 in the entire expression. Alright, now let's factor out x minus 2. So we have x minus 2 times x minus 1 plus a. Now let us expand x times x minus 1. So we have x squared minus x plus a. Alright, so this is now our final answer. Okay, second example. Factorize x raised to 9 plus 7x raised to 6y cubed plus 7x cubed y raised to 6 plus y raised to 9. We can group, notice that if we group x raised to 9 and y raised to 9, we can actually form a sum of cubes. Alright, because x raised to 9 is the same as x cubed raised to 3, and y raised to 9 is the same as y cubed raised to 3. So we have x raised to 9 plus y raised to 9 plus 7x raised to 6 y cubed plus 7x cubed y raised to 6. Notice also that we can factor out 7x cubed y cubed in the last two terms. Alright, now again, this is the same as x cubed plus y cubed plus factor out 7x cubed y cubed. We have 7x cubed y cubed times x cubed plus y cubed. Alright, now we can apply here the sum of cubes formula. Recall that the sum of cubes formula, I'll just write it on top, is a cubed plus b cubed equals a plus b times a squared minus ab plus b squared. Okay, so here we let a be equal to x cubed, and b be equal to y cubed. Okay, so applying the formula, we must have x cubed plus y cubed times x cubed squared minus x cubed y cubed plus y cubed squared. And take note, we still have here plus 7x cubed y cubed times x cubed plus y cubed. And now we produced a common factor once again, which is x cubed plus y cubed. This one and this one, right? Now let's factor this out. So we have x cubed plus y cubed. And then let's simplify each of this. We have x raised to 6 minus x cubed y cubed plus y raised to 6. And of course, we still have here plus 7 x cubed y cubed. Now, we can still factor this. That is sum of cubes, right? So we have x plus y times x squared minus xy plus y squared times x raised to 6 negative x cubed y cubed plus 7x cubed y cubed is positive 6 x cubed y cubed. And finally, we have plus y raised to 6. And so this is now our final answer. Alright, now let's have our third example. Factorize x squared minus 1 times x plus 3 times x plus 5 plus 16. Alright, so based from the structure of the original expression, the natural first step to do is to factor x squared minus 1 because that's a perfect square. Alright, so if we factor that, we get x plus 1 times x minus 1 times x plus 3 times x plus 5 plus 16. Now, you can expand by multiplying all the four factors. However, that will produce a lengthy expression which might be difficult to analyze, right? So what I'm going to do now is regroup the factors. For example, I can regroup by putting together x plus 1 and maybe x plus 3. So I'll have x plus 1, x plus 3 side by side, and then x minus 1, x plus 5. So why did I do this? Notice that I can write x plus 1 into x plus 2 minus 1, and then x plus 3 can be written into x plus 2 plus 1. So now I have a difference of squares. In the same manner, I can also write x minus 1 into x plus 2 minus 3, and x plus 5 can be written into x plus 2 plus 3. Once again, we have a perfect square. Alright, now to make this clear, although this is not really needed, I'm going to let y be equal to x plus 2 just to illustrate further. Okay, so if we're going to let y equals x plus 2, then this one will become y minus 1 y plus 1 times y minus 3 times y plus 3. Okay, so substitution method can sometimes simplify the process of factoring. That's why it's also a very important technique in factoring. Now, it is very clear that this is a difference of squares. So we have y squared minus 1 times y squared minus 9 plus 16. Right? Now, we can expand uh, y squared minus 1 times y squared minus 9. So we're going to have, so I'm just not going to use parentheses. Okay, so we're going to have y raised to 4 minus 9y squared minus y squared plus 9 plus 16. So this is going to be y raised to 4 minus 10 y squared plus 25. Now this is a good thing because this is a perfect square trinomial, because this is the same as y squared minus 5 squared. Now take note that y is x plus 2, right? So I'm just going to continue to write here. I can replace y by x plus 2. So this is going to be x plus 2 squared minus 5 squared. Alright? So we have x squared plus 4x plus 4 minus 5 squared, and finally the answer is x squared plus 4x. This is going to be negative 1, right? So the final answer is x squared plus 4x minus 1 whole squared. So that's the factored form. Alright, let's have example number 4. Factorize this given expression. Alright, so we have a trinomial raised to 2, and it seems that we can recreate 2x squared minus 4x plus 1 in the remaining 3 terms, in the last 3 terms, because what I mean is that we can have here a 2x squared minus 4x plus 1 if we subtract 7. Alright? So if we subtract 7 from negative 14x squared plus 28x minus 7, and of course we add 7 to balance it, we can actually factor out negative 7 and produce again 2x squared minus 4x plus 1, and then make a substitution. So this is going to be 2x squared minus 4x plus 1 squared, factor out negative 7, so this is positive 2x squared minus 4x plus 1, and this is going to be plus 10. Now, just like in the previous example, I'm going to let y, you can use any other variable you want, but here I'll just use y. So we can let y equals 2x squared minus 4x plus 1. Alright, so we have what? Y squared minus 7y plus 10. Now it's obvious that this one is factorable. This is the same as y minus 2 times y minus 5. However, y is 2x squared minus 4x plus 1. So replace again y by this. 2x squared minus 4x plus 1 minus 2 times 2x squared minus 4x plus 1 minus 5. Now, if you're not comfortable with substitution method, you can just immediately factor. However, with substitution method, chances of errors in writing the answer or in simplifying is reduced. Alright? Now, if we simplify this one further, we have 2x squared minus 4x minus 1 times 2x squared minus 4x minus 4. Now, be careful because the second factor can be factored by factoring out 2, right? So, the final answer here, now we factor out 2, so we put 2 in front. Here is x squared minus 2x minus 2. Alright, so this is now our answer. Example number 5. Factorize x raised to 4 minus 2 times a squared plus b squared times x squared plus the square of a squared minus b squared. Notice that if only we have the term here a squared plus b squared squared, then we have a perfect square trinomial. However, we can introduce that term, but we have to subtract the same term. So we have x raised to 4 minus 2 times a squared plus b squared x squared plus a squared plus b squared squared. But we have to subtract the same quantity, minus a squared plus b squared squared. We still have the last term, a squared minus b squared squared. Now, let us factor this part, that is x squared minus a squared plus b squared squared. That's a perfect square trinomial. Alright. Now, what I'm going to do next is expand a squared plus b squared squared as well as a squared minus b squared squared, because we see that if we do that, a squared and b squared, I mean a raised to 4 and b raised to 4 will cancel, and you will be left with a single term, which is a perfect square. Okay, what I mean is that we will have a raised to 4 plus 2a squared b squared plus b raised to 4 plus a raised to 4 minus 2a squared b squared plus b raised to 4. Now, if we distribute the negative sign in the second group of terms, we actually cancel a raised to 4 and b raised to 4. And also, we will have 2 copies of negative 2a squared b squared. So that gives us negative 4a squared b squared. So I'm going to write this one as x squared minus a squared minus b squared minus 4a squared b squared. And now we have a perfect square, right? So we can again apply the difference of squares formula here. So this is going to be x squared minus a squared minus b squared plus 2ab times x squared minus a squared minus b squared minus 2ab. Now, this is not yet the final answer, because if you rearrange the terms with a and b, we actually have a perfect square trinomial. Now, notice that we have x squared minus a squared minus 2ab plus b squared. And in the second group, we will have x squared minus a squared plus 2ab plus b squared, if you rearrange the terms. Alright, now this is the same as x squared minus a minus b squared. The second group is the same as x squared minus a plus b squared. Now, once again, we have a perfect square. So we can factor each of these factors into x plus a minus b times x minus a plus b. So I'm just distributing immediately the negative sign, alright? And then here we have x plus a plus b times x minus a minus b. Alright, now let's check first if we are doing the right thing. So in the first part, we must have x plus a minus b times x minus a plus b. Alright, that's correct. And then in the second part, we must have x plus a plus b and then x minus a minus b. Alright, so this is the final answer. Okay. Let's have example 6. Factorize quantity ab plus 1 times quantity a plus 1 times quantity b plus 1 plus ab. If we're going to expand the product, then you will have a very lengthy expression. So what I'm going to do first is expand the last two factors. So I'll have ab plus 1 times ab plus a plus b plus 1 plus ab. Alright. Now, notice that if we regroup the terms in the second factor in the following manner, what I mean is ab plus b plus 1 plus a, and then multiply ab plus 1 to ab plus b plus 1 separately with a. Okay, so what I mean is that we can have ab plus 1 times this, so that's ab plus b plus 1, and then this one times this, so we have ab plus 1 times a. I'll just put a in front and then plus ab. Notice that we can actually factor out a here, and then we can produce the common factor ab plus b plus 1, which is also here, right? So we have ab plus 1 times ab plus b plus 1. Factor out a, you will have a times ab plus 1 plus b. Alright? So if we rearrange ab plus 1 plus b into ab plus b plus 1, we can factor out also ab plus b plus 1. We will have ab plus b plus 1 times ab plus 1 plus a. Now let's just rearrange the terms. So ab plus b plus 1, ab plus a plus 1. Alright, so this is our final answer. Let's have our last example. We have 4x squared plus y squared plus 9z squared minus 6yz plus 12zx minus 4xy. Alright, so if you notice, this expression somewhat resembles the identity quantity a plus b plus c squared equals a squared plus b squared plus c squared plus 2ab plus 2bc plus 2ac. Alright. Now, notice also that the original expression can be written into 2x squared plus y squared plus 3z squared plus 2 times negative y 3z plus 2 times 2x times 3z plus 2 times 2x times negative y. So this means that this must be negative y squared. So in this case, this is A, this is B, this is C, this is B, this is C, this is A, C, A, B. Which means that that expression is the same thing as 2x minus y plus 3z squared. Alright, so this is now our final answer. Okay, so our examples show that there are a lot of factoring techniques you can apply. So it actually depends on the given expression. So you can use a substitution method to simplify first the expression. You can also regroup the terms to produce, let's say, difference of squares or sum of cubes. Or just like this final example, you can apply directly the appropriate algebraic identity. Okay? However, it depends on whether you're really familiar with that certain identity, because you have to recognize the structure of the given, whether it is the same as the structure of the given identity. Alright? Now, you can also combine 2 or more techniques depending on the given expression. If you find this video useful, please share and subscribe. Thanks for watching.